Welcome to this live whereby we're going to have a discussion. Let me just get to know whether you can be able to hear me from the other end. Are you able to hear me? Is the audio okay? Let me get to know whether you can hear me from the other end so that we can be able to start. And the paper that we have here is basically IAL Unit 2 Physics. And this is going to be the final cut so that we can be able to get rid of any confusion as far as Unit 2 is concerned. So first, before I start, I would like to know whether you can be able to hear me from the other end. Just write in the chat section that you can hear me loud and clear. If you can hear me, then we can be able to proceed. If you can hear me from the other end, let's can just write a comment. The other end. So this is Jan 2023 paper that was tested, and we are told that the graph shows current, how current varies with potential difference V for a potential for an electrical component. Yeah, let me get to know whether you can hear me from the other end. If you can hear me, let me get to know. I don't know whether this live is on, so let me know from your end whether everything is okay there so that we can be able to continue. I cannot hear anybody. I cannot see any comment, so meaning maybe you cannot hear me. So this component represented by the graph, this is a straight line, means it obeys Ohm's law, and this is basically going to be a resistor at constant temperature. Monochromatic light travels through air and enters a glass block. Which of the following quantity does not change? Of course, the frequency is not going to change because speed is going to be affected. The ray of light approaches the boundary between air and the glass as shown. The angle of incidence is I. Which of the following statement about total internal reflection is correct? So if it's moving from air and it's moving from air into glass, so what does that mean? That means that this ray of light is moving from a less dense medium to a dense medium. So it means total internal reflection can never take place in such a scenario. Total internal reflection cannot take place because it's moving from a less dense medium to more dense medium. For question number 4, if you have any question, you can just write in the chat section if you have any question. If you are having any question, write in the chat section so that I can respond to them. All right, so the equation n lambda is equals to, this is actually for diffraction grating, and we are told that d sine theta can be used to determine the wavelength of laser light that has passed through the diffraction grating. Which of the following represented by d? D is the distance between the adjacent lines of diffraction. Lambda is the wavelength of the light of the wave that is passing, or the light, and d is the distance, and n is the number of the order, and this is the angle that is made between the lines, the rays of light after they have passed through the diffraction grating. So we can say rather d is the distance between adjacent line, the diffraction grating. A bat is an animal that locates objects using pulse echo technique. In order to find the distance, we know that speed is equal to twice the distance over time, because the pulse will travel and then come back. It will cover twice the distance. So that's why you can see we have this formula here, and if we work it out, we are going to get our answer equals to C. That is for multiple choice part. Light dependent resistor is connected in a circuit as shown there. Now the intensity of light resistor decreases if the intensity, I think my internet has disconnected, I don't know why. I don't know whether you can hear me from the other end. My internet is quite misbehaving from this end. All right, I think now we are back online. We are online. So intensity decreases. So what happens to the ammeter reading? So if intensity decreases, it means that a resistance increased. If intensity of light decreases, resistance will increase, so which means the amount of current that is flowing into the circuit is going to decrease, because if resistance increases, the overall resistance of the circuit is going to go high, and if resistance increases, current decreases. Also, it means that there will be a large potential drop on this light dependent resistor. When there is high resistance, there will be a large potential drop, so meaning the voltage here will go low, the voltage will decrease, and it means that the best option for that is going to be A. For number 7, we are told the diagram shows some energy levels in an atom. Electron in an atom is excited and move from the ground state to the energy level N. So which means is moving from this to that. So it's moving from this point, it comes here, then it goes to the other side. How many different energy radiations is it going to move from the ground state? That's going to be 3, because it needs some energy to move from this energy state. It comes here. Then from 2, it also needs a given discrete amount of energy for it to move the next one. So it has moved 3 of them, not 2. I know most of the students will say 2, but it's gonna be 3. The longitudinal wave passed through a material. Compression and rarefactions are formed. Which of the following statement is correct? Compression and rarefactions are formed. So compression are points where displacement particle is maximum. No, that is not true, because that's a compression's region of high pressure. and there are fractional points of minimum pressure and compression and region of maximum pressure. So the correct answer in that case is D, without wasting any time. This is a marathon to ensure that we are on time. Question number 9. A lamp is connected to a circuit as shown. The cell has negligible air resistance, negligible internal resistance. Which of the following gives the energy in joules transferred by the cell? So what you are supposed to remember is that you need to remember this formula that energy is charge is equal to current times time, and also you need to remember that energy is equal to IVT, isn't it? IVT is the formula for energy. Which information do we have? We have charge. So using this one, we can be able to know the amount of what? Current. And also we need to remember that energy is equal to voltage times charge. So we can be able to use that. Since we have the voltage here and we have the charge, we can use direct this formula and get our answer to be B. These are other options, other formulas you need to know in this unit. So that's why I decided to bring them on, so that if you are asked a question on that line, you'll be able to answer that is in the exam of tomorrow. Okay, so question number 10, which is going to mark the end of multiple choice. Which of the following is not correct about stationary waves? About stationary wave, all points between adjacent nodes are in phase. So if we are having a stationary wave, let me just draw, like for instance, we have a stationary wave like that, and then we have the reflected form here. This is a node, this is a node, this is a node. So we have a node here, we have a node there, and we have another node at that given point. All points between two adjacent nodes are in phase. Adjacent, all points between two adjacent nodes, all points are in phase. Not correct. Not correct, because that is true. If you have any point here, 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 so long as they are between two adjacent nodes, all these points, if we can call them A, B, C, they are in phase. And if we have another point, let me say we have another point here, 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 let's say this is a point D. This point D is exactly out of phase with point C. They are anti-phase so long as they are in adjacent loops. Antinodes are point of maximum amplitude. That is true. Distance between adjacent node is equal to one wavelength. That's not true, because distance between one and another node is a half a wavelength. This is a half a wavelength. So the correct answer is C, because it's wrong and we were choosing a point that is not correct. So that is multiple choice for Jan 2023. Jan 2023. Multiple choice for Jan 2023. All right, so let's look at the next part. Now we're told that a particle is traveling at a speed of 9.89 times 10 raised to the power 5 meters per second, has a de Broglie wavelength of this. So we need to remember that that is Planck's constant of P, where P is basically what? The momentum of that wave particle. So the wavelength is given here, so which means that we can be able to substitute the wavelength, which is 7.37 times 10 raised to power negative 10 is equals to Planck's constant is 6.6 what? Yeah, you need to Planck's constant, you don't have to cram that, you can check it down here. Planck's constant is given here 6.63 times 10 raised to power negative 34. 6.63 6.63 times 10 raised to power negative 34 over the momentum, yeah, so which we can say that momentum is going to be equal to 6.63 times 10 raised to power 24 divided by 7.37 times 10 raised to power 10 negative. So if you work it out, can you write in the comment section what would that value give you? You guys, you don't have to keep quiet, just write in the comment section so that I can know we are together and you can be able to hear me. Minus 34. 7.37 times 10 raised to power negative 10. So the momentum in that case, basically the momentum is equivalent to 8.996 times 10 raised to power negative 25. So when you have this, this is the momentum. We know that momentum is equals to mass times velocity, so which means we are going to find the mass, and mass will be the momentum over the velocity at which it was moving, so which is 8.996 times 10 raised to power 25 negative divided by the velocity at which it was moving, and the velocity is 9.89 times 10 raised to power 5. So that if we divide that, the answer becomes 9.1 times 10 raised to power negative 31 kg. So we were deduced whether this particle has the mass equal to the mass of an electron, which is true. This is true. True. Because if you go down there and then you try to check the mass of an electron, what's the mass of an electron? Is 9.1 raised times 10 raised to power negative 31, and exactly that's what we have gotten. It's just close to that, huh? It's true, it has the same mass, the mass of the electron. Yeah. Yeah, so we can ascertain that there's some truth in that. Right, so we have a question also here. We need to determine the refractive index We need to determine the refractive index of glass. So for us to determine the refractive index of glass, the first thing that we need to do is to draw the normal and get the normal there. Once you've drawn the normal, you will understand that the angle we were given is not the angle of incidence. So the angle of incidence is this, and the angle of refraction is going to be this one here. So which means that this is going to be 40, and this angle is going to be 90 minus 32, which is going to be 58 at this given point. So for us to find the refractive index, we are going to say is sine of angle of incidence divided by the sine of angle of refraction, and this is going to translate to sine of 58 over the sine of what? 40. So if you put this in the calculator, we are going to say this is sine 58 over sine 40, and you are going to get your answer, which is approximately 1.3 as the refractive index of glass. 1.3 as the refractive index of glass. Draw on the diagram the ray of light as it emerges from prisms at A. No further calculation is required, but you need to remember that also you need the normal at that point, the normal. But since the ray of light is moving from a dense medium to less dense medium, it will slow down, and it will be, it's moving from a dense medium to a less dense medium. It will speed up, and then it is going to move away from the normal. So the ray is going to move out, it's going to speed up, and then it's going to bend away from the normal, and that is how the ray is going to emerge out of the glass. Now, a different prism is made of glass with a refractive index of 1.63. Calculate the speed of light in this glass. So we know that the concept we're going to use here is that refractive index is equals to speed of light in a vacuum divided by speed of light in the material. Speed of light in glass. So which means it's going to be 1.63 is going to be equals to 3 times 10 raised power 8 divided by V, and this is going to be V is equals to 3 times 10 raised power 8 divided by 1.63. If you work it out, you are going to get your answer as what? Using your calculator, you're going to get 1.8 times 10 raised power 8 meters per second. Meters per second, just like that. Yeah, we have also another interesting question number 13. Question number 13 is another interesting question.